Good day. Today we will talk about the method of crystallographic indexing. To the plan of our lecture and a few words about the method. The method of crystallographic indexing allows to determine any point, direction, plane in a crystal structure independently of the coordinate system. The first, the indexing points and directions. To describe the crystal polyhedron, there is used the method of crystallographic indexing that is convenient for any crystallographic coordinate system. Let's get acquainted with this method. If one of the sides or units of the lattice is selected for the beginning of the coordinate system, any lattice unit is determined with the radius vector. Here you can see where M and P are three numbers which are called the index of the site and its coordinates. The set of numbers M and P written in double square brackets, M and P is called the symbol of the unit. The numbers are written in a row without commas. The minus sign is placed above the figure. Here you can see the fractional indices. Here. The set the set of numbers M and P written in double square brackets is called the symbol of the site. Here you can see the example. A series or a unit line as well as a crystal rib is characterized by the slope in the selected coordinate system. If the series does not pass through the origin of coordinates, we mentally more it so that it passes through the origin of the coordinates. Thus, the directions of the series is defined by 2 points, the origin of coordinates and any unit of the series. The symbol of this unit is taken as a symbol of the series and is written in square brackets, M and P, only integers. Obviously, this symbol describes a family of parallel series and parallel ribs of a polyhedron. The direction symbol is the coordinates of the node lying on this direction and closest to the origin. And the direction symbol can be positive, negative, but only whole. Here, this example is symbol of direction. Crystal edges are intersected the parallel edges, and the general direction of these edges is called the axis of the zone. Here you can see the advantage of crystallography and indexing. Symbols of axis don't depend on the angles between the coordinate axis and the axial segments. Planar grips in the space lattice and the corresponding faces of the polyhedron are also characterized by a slope in the given coordinate system. Each crystal face is a parallel to the planar grid, an infinitive number of planar grids parallel to it. And now we will tell about the indexing of planes. Let's suppose that a certain lattice plane intersects all coordinate axes intercepting M, A, and B, P, C. The ratio of numbers M and P characterizes the slope of the plane to the axis. Thus, we have the following family of planes. Here you can see the segments cut off by a plane, a family of planes. This table is given indexing of planes. A series of relationships numbers m and p for all parallel planes can be represented as a ratio of integers relatively prime numbers P, Q, R that are the basis parameters. So, for the given plane, we can write this equation. You can see, and of course, letters P, Q, R is equal 3 to infinity is the base parameters for this plane. In crystallography, there is a rule to characterize the planes not with the base parameters, but with so-called Miller's indices. Miller's indices are the reciprocals of base parameters given into integer numbers. They are denoted by h, k, l and are defined by the ratios 1 derived p, 1 derived q, and 1 derived r is equal h, k, l. As example, you can see here for the given example we have 2, 3, 0. The numbers h, k, l are called the indices of the plane. Indices written consequently in parentheses are called the symbol of the plane h, k, l. For example, consider 2, 3, 0. The symbol HKL is characterized by the entire set of parallel planes. This symbol means that the system of parallel planes intercepts a segment in H parts, B in K parts, and C in L parts. Cuts of segments are A derived H, B derived K, and C derived L on the coordinate axis. The method of crystallography indexing had been established long before crystal lattice structure was proved by Hayui in 1912. It was based on a remarkable empirical law of crystallography called the law of integers. We will tell about this law later. Thank you. Good luck.